So you should have read through sections 15.1 and 15.2 at this point. Those cover defining a class, and it defines the point class that we'll use in a second, and instantiating that class, using it like a factory to create new instances, new objects of that type of class. And it introduces this notion of using this dot notation to reference individual attributes of the class. You might also have heard of attributes called properties or sometimes instance variables in other languages. We can use this dot notation anywhere, pretty much anywhere you could use a regular variable. You can use it in expressions, you can pass it as arguments, and so on. And then it's going to ask us to write a function to compute the distance between 2 points. And that's what we're going to do here. We're going to compute the distance between 2 points. Before we do that, let's review a little bit of math so we can remind ourselves how to compute that distance. If you have 2 points, A and B, and A has at x1 and y1, and B is at y2 and x2 and y2, then you can compute the straight line distance between the points this way. First, you find the distance between the 2 points along the x-axis, then you find it along the y-axis, and then you take the square of those two differences, sum them all together, and take the square root of that, and that gives you the distance along the hypotenuse of that triangle. So let's go look at that. Here is the point class that we saw in the text. Notice that it is introduced, it's defined by using the class keyword, the name of the class, and then the colon. And in this class, all we've done is we've created a comment, a header comment, a docstring. The comment, it doesn't actually do anything, but it does give us the hint that this class is anticipated to have 2 attributes, x and y. That's the x and y locations. So let's, in the spirit of incremental development and building and testing, let's create 2 points that are instances of the point class. So I'm going to call point 1 the first instance. And remember from the text, you create an instance of a class by calling the class as if it were a function. And then you can assign values to attributes of that class by using the dot notation. Point1.x equals 100, point2.y equals 100, and I've just defined a point at 100, 100. I'll do the same thing for a second point. Call the class as a function, and I'll put this point at 200, 200. Now, let's go visualize what we have so far and watch it in the visualizer. So as we step through the code, first thing it does when it encounters the class definition is it creates a reference in our global frame to that class. When I then call and create an instance of that class, it creates the point1 variable, which is a reference to that instance. And then when I assign values to the x and y attributes, notice, oops, I made a mistake. So notice, we'll go back a step. Notice when I assign a value to the point1.x, it adds an attribute to that instance of the point and assigns the value. Now, in the spirit of debugging, we will go back, edit our code, fix my typo, point1.x, point1.x, and we will rerun the code. Create a pointer to the class, create a reference to the instance, and now it's created correctly both attributes on the point 1 instance. And we can do the same thing for point 2. Create the instance, assign an X attribute, assign a Y attribute. Okay, so far, so good. We've got the 2 points. Now, let's create the function distance between points. We'll go back and edit our code. Now, since we're going to be using the square root function, we need to import the math module. And I'm going to define my function right here. So we use the def keyword, distance between points, which is the name of the function, and the 2 parameters, P1 and P2. Oh, and I need the colon. So now that is in there. So if you remember back to our little diagram, I'm now going to compute the distance along the x-axis, distance along the y-axis, and then I'm going to compute this square root of the sum of the squares. So dx is going to be p1.x minus p2.x. Notice how we are using this parameter, and then we're simply referencing the x attribute. Same thing along the y-axis, p1.y minus p2.y. We'll compute the distance along the hypotenuse as the square root of the sum of those 2 squares. So dx times dx plus dy times dy. And the last thing we got to do, return the distance value. So now we have our function defined. Let's test it and see if it works. So I'm going to add a line at the bottom now where I call and print the value of distance between points. And since I'm calling the function now, I've got to pass the arguments using the points that I defined in the main frame here, point 1 and point 2. Now let's see if I got it right. So we'll visualize that and walk through it. So, first thing, notice when I import the math module, it actually creates a reference to the module in the frame, in the global frame. And then it goes through and it creates the point class, and it also creates a reference to my function now, because it's defined that. And now we go through and we instantiate our 2 points. Okay, now it gets interesting because we're going to call our function. And notice what's happened here. When I call the function, first of all, it creates a new frame, because each time you call a function, it creates a new frame, and the variables inside of that frame are local to that frame. And it's initialized my 2 parameters with the values that were passed to it. And notice also that P1 is initialized to this point instance, point 1. What we can see is that the point objects, in fact any object, is passed as a reference to that object. So P1 is actually pointing to the exact same thing that point 1 references. Similarly, P2 references the same thing as point 2. Now, as we move through the code, we will compute the distance along the x-axis and along the y-axis. So we see it's a difference of 100 on each side. And then we will compute the distance along the hypotenuse, 141 units. And the last thing, you got it, it'll return the value. Okay, so now this function is about to return. We return the value, and notice that since we've exited the function, it's now forgotten, it's tossed off the stack. That frame is no longer available. And the value of 141 has been passed to the print statement, and it's printed it out. So there you have it.